In this lecture, we'll talk about some of the key concepts related to computer graphics and game development. While you may be familiar with some of these concepts, I want to go over this to fill in any gaps that you may have in your knowledge so that we can communicate effectively as we move forward across the course. To do this, we use the graphics display model. In this model, we have the display layer, where we see the graphics. Underneath the display is the model layer, where the graphics are represented internally within the computer or within the game. This representation, of course, is rendered to the display. And of course, the graphics need to be saved and loaded from storage, so we have the file layer. This model maps to the hardware, the application, and file formats. We'll discuss each of these in a bit more detail. Today, displays come in many different shapes and sizes, from the display on our desktop and laptop to our smartphone and tablet, or even our smartwatches and virtual reality glasses. In general, they all work the same. Images are displayed by emitting light to create a grid of small dots that our eyes perceive as an image. One of the most important differences when distinguishing between displays is the resolution that the display supports. But what do we really mean when we say resolution? One definition of resolution is a measure of how accurately a display approximates continuous images using finite pixels. Resolution can be measured in several ways. One of the most important for us in game development is the pixel dimensions of the display. That is, how many pixels can be rendered horizontally by how many pixels vertically. Of course, the more pixels available, the higher the resolution, the more detail we can present on the display. Another measurement of resolution that you sometimes encounter is dots per inch, or DPI, or pixels per inch, or PPI. The concepts of dot per inch is most important when discussing print applications and are not that important in game development, except of course when we go to print our game poster. Pixels per inch you can think of as how many pixels can fit based on the size of your display. The more pixels per inch, the higher the pixel density, resulting in crisper text and images on the display. Of course, today we use terms like high-definition display, 5K display, and retina display to reflect the fact that our pixel density is so high that the human eye does not perceive the pixels individually when viewed at a typical distance from the display. A curve, for example, looks like a smooth, continuous bend versus a jagged approximation made with blocky pixels. Another display concept we should be familiar with is that of aspect ratio. The aspect ratio is the proportional relationship between the pixel map's width and its height. It is commonly expressed as two numbers separated by a colon. 16:9 is the standard for a high-definition display today. Standard definition displays were typically 4:3 or 3:2 aspect ratio. Of course, the resolution or pixel dimensions, pixel density, and aspect ratio are all important concepts to grasp when designing the visual layout of our game and its interface. Another important concept is that of refresh rate. The refresh rate is how quickly the display hardware refreshes the image on the display. Refresh rate is often expressed in hertz, or the number of times per second. The faster a display refreshes, the less flicker in the display. 60 hertz, or 60 times per second, is required for most people not to exhibit any discomfort when looking at a display. Most modern LCD displays have a refresh rate of at least 60 hertz. Higher-end displays today have refresh rates of 120 hertz or more. While refresh rate is a measure of how often light is emitted from the display, frame rate is how often the display hardware can update the entire image on the display. A display may have a 240 hertz refresh rate, but because of the complexity of the game, the display hardware may display less than 60 frames per second. When the hardware can't keep up, the same frame of content is refreshed multiple times, as shown here. The human eye can perceive individual frames at anything under 10 to 12 frames per second. It basically starts looking like a fast slideshow. At over 12 frames per second, the frames blend together to create a more seamless motion. In games, we strive to maintain at least 30 frames per second, and often we try to hit 60 frames per second or above. Obviously, the computer power, resolution of display, and the complexity of the games all affect the frame rate. In the next video, we'll discuss the model layer of our graphics display model.